Hi, my name is Hugh from SRI Instruments. This is a valve chassis. We call it a 20-stream selector chassis because it allows the GC to measure 20 different gas streams under the control of the data system. Inside this box there are two very expensive Valco valves that look like this. There's this one here and this one here, valve A and valve B. And what appears to be happening, unfortunately, is that one of the parts inside this tends to break frequently. So there's a new part, a stronger part, that we've asked Valco to make for us, which looks like this. We call it a drive shaft. And what it does is it's the connection between the valve and the actuator, and the previous model just wasn't very strong and it tended to break. So this video is going to show you how to replace the drive shaft inside this valve chassis. You'll have to do it for valve A and do it again for valve B, but the video will just show you how to do it for valve A because it would really be the same thing on valve B. So the first step is to remove all the little brass thumb screws that are inserted to hold the top of the valve chassis to the base plate. So there's going to be about a dozen of these little brass thumb screws that you have to remove. And then it's also a good idea to position the valve so that it's in position 1 to start with. So this is the little keyboard controller that controls the position of the valve. You can see I'm changing it from position 1 to position 3 to position 4, and then all the way back to the home position, which is position 1. So start the process with the valve in position 1. Okay, so the next step is to remove all of these tubes from the valve head. And this is kind of a tedious process, and you don't want to get things mixed up. So it's a good idea to write down the tube number before we even get started. So I'm going to go ahead and do that. So this is tube number 1, and this is tube number 2, and this is tube number 3, and 4, and 5. And I'm going to remove these 5 tubes first, and then go and do the other 5 when I can reach them. So I'll remove these first 5 now. So the trick with this is to loosen this nut here that holds the bulkhead fitting in place, because the bulkhead fitting has to slide outward in order to provide enough flexibility to get this tube out. So the first thing is to loosen this nut like so, and then the next step is to loosen this nut and this nut. Okay, so make sure you mark these because it's not always easy to figure out where they go back if they're not marked with the number. So we'll take that number 1 and put it off to the side, and then do the same thing for numbers 2 through 5. Okay, well, now that I've gotten tube number 5 out, I'll go and mark numbers 6 and 7 and 8, 9, and 10. Yeah, make sure you mark them good with the magic marker. And then also the size of the wrench is a 5/8 inch wrench for this nut that holds the bulkhead fitting in place, and then it's a 1/2 inch wrench for that squage lock nut. And you can see how you have to pull the bulkhead fitting back in order to have enough slack to get this tube out. And then it's a 1/2 inch wrench for the Valco fitting that actually goes onto the head of the valve. Okay, so I've got all the 10 tubes out, but then there's an 11th tube on each valve, which carries whichever one port is selected off to the GC. So we have to remove that tube also. So that's this tube here. So remove it from the valve. And then the other side of it goes to this solenoid that's sitting here, this solenoid here. So I'm loosening the fitting and both sides, but it's a little hard to wiggle out until we actually take the head of the valve off. So that's what I'm going to do next. Okay, well now we're ready to take the valve head off. And before we do, let's mark everything so that we put everything back together in exactly the same way. So I'm going to make a mark here, I'm going to make a mark there, I'm going to make a mark here, I'm going to make a mark there, I'm going to make a mark here, so that everything can go back together exactly the way we found it when we took it apart. So the first thing to do is to loosen the collet. The collet is the thing that on the actuator that holds this valve. So there's a set screw. I believe it's a 9/64 set screw. So this, you need a little hex wrench, and you need to loosen this collet. So to loosen the collet, there's really 3 screws. There's 2 screws that holds the collet onto the actuator, and then there's a 3rd screw that tightens the collet. So you really have to loosen all the screws kind of simultaneously, and then once you do that, you can see that this is free to pull out. See how that comes out like that? So this is the head of the Valco valve that we need to remove. So we're going to take this nut off. It should be just kind of hand tight. You don't really need to take a wrench or anything to it. So there's the head of the wrench, and then here is the inside. This is the rotor that turns, and you can see that it has a groove and it has various holes. So the groove lines up with the holes, and this is going to be important when we put it back together, because you have to make sure that this groove is lined up so that it's selecting position number 1. And then this is the drive shaft that we're talking about. So this is the bad one, and this is the good one. The way you can tell the difference is that this piece here is a separate piece of metal called a sintered metal casting. So they squish little particles of metal under high pressure to make this kind of in a mold. Whereas this one here, the new and improved one, is all machined out of a single piece of stainless steel. So there's nothing to break, or at least we certainly hope it's not going to break. It should be a lot stronger, because the single piece of stainless steel is much stronger than this assembly of sintered brass. Again, remember, this is not SRI's part. This is Valco's part. And we got them to make an improved part because we were seeing this part of the drive shaft break off after several thousand or tens of thousands of cycles. It just wasn't strong enough. So we're hoping that this is a more reliable part overall. So this is the bad one, and this is the good one. So the good one goes in instead of the bad one. So we'll put this in like so, and then the rotor, nice clean rotor, that one, not too dirty, put that in, and it actually has a little mark here on the bottom of the rotor that's lined up with this pin, and this pin has to be position 1. So position 1 is this one here right next to the 11th connection. So this is maybe hard to see on the video, but this little slot in the rotor, you see there's 10 little drilled holes or divots, but one of them has a slot. So the one with the slot has to be lined up under position number 1. So you have to engage the rotor in that drive shaft and then turn it so that you can actually see the slot in position number 1, and then tighten up this nut again, making sure that the slot that you can see through the hole is still lined up with position number 1. So if that's true, then it's time to put everything back together. So we'll slip this back in like so, and then this should engage into the actuator. See, I'm having a little trouble getting that to engage in the actuator, not sure why. So I've got the valve ready to put back in the actuator, and everything should line up the way it was. It's a good idea to blow through from the common port to port 1 to make sure that you are still in the correct position, and everything should be lined up. So let's make sure of that. So we'll connect port number 1. And then we'll blow through from here through, and the sample should come out this this common port. So let's do that. Alright, so with the valve head reassembled, before we put it all back together again, it's probably a good idea to test this and make sure that we've put it back together correctly. So what I'm going to do is I'm going to take the common outlet tube and stick it in this drinking water, and then I'm going to blow through from position 1. So you can see that when I blow there, it's definitely coming out. So I know that this is now lined up so that we are connected physically with the rotor to position number 1. And now I'm going to try to put it back together. So we've got it kind of tentatively back together. All the little magic marker marks that we made before are still lined up. So now I'm going to tighten that collet up so that the position doesn't change. So here I've got my hex wrench in that collet tightening screw. I'm going to tighten that up nice and tight. And then the 2 screws that hold the collet onto the actuator, didn't actually remove them before, just had to loosen them. So I'm going to take those and tighten those up. We've got this apart to this extent. It probably makes sense to replace the drive shaft on valve number 2, valve B, even though it hasn't malfunctioned up to this point in time. It's probably just because there's probably more usage on valve A than there is on B, but we know it's going to break eventually. So as long as you're inside the unit and replacing the drive shaft on valve A, we might as well go ahead and do it on valve B also. So I'm just going to repeat the process that we went through on valve A, make magic marker marks, and loosen the collet, and then go ahead and loosen each tube, of course being very careful to write down the tube number so that there's no confusion when it goes back together.